In this video, we are going to introduce a new kind of function called a piecewise function. A piecewise function is a function defined by different rules on different parts of its domain. Here I have two different functions that you're probably familiar with and probably could graph. On the left, we have f of x, which we know to be a linear function. If we were to graph it, it would take the shape of a line. On the right, we have g of x, which is x squared plus 6x minus 5. This falls into the family of the quadratics, and it would take the shape of a parabola if we were to graph it. Thinking of these two graphs separately, I would have a line and a parabola sharing the same xy coordinate system. But thinking of them as a piecewise function, I could take elements of both functions and combine them together into one newer function. Naming this new function f of x, I really should have named it something else. Because I already have an f and a g, I should have named it something like h or m. But for the purposes of this exercise, let's just call it f as our new function. We're going to take elements of both. But in order to get elements of both, we write our function as having both of those components. We have in this case, a quadratic component and a linear component. But if I just graph this, I would end up with this sort of cross of both of them that I do not want. Now I want to employ the other part of the definition, which is I want these defined on different parts of the domain. Both the linear and the quadratic by themselves have a domain of all real numbers. So I need to restrict this so that there is no overlap between the graphs. For the purposes of this exercise, I've chosen to restrict it at the number positive 1. So I'm going to say that the parabola exists only when x is less than or equal to 1, and that 3x minus 2 only exists when x is greater than 1. Looking at those two restricted parts of the domain, I see no overlap between the two of them. The quadratic section will go up to x is less than or equal to 1. The linear section will start after x is 1. Occasionally, you will see piecewise functions were written with the word if. So I am this function if my x is less than or equal to 1, and I am this function if my x is greater than 1. Graphically, this looks exactly what you're probably thinking. This looks like exactly what you're probably thinking, which is you're going to have part of a parabola and part of a line. And this is the graph for that particular piecewise function. You'll see that the parabola starts over on the left as all of its x's are the x's less than or equal to 1, and comes all the way down and continues its formation all the way to x is 1. It's at that point where the function transitions from being part of the parabola to now creating the line. And then we can see that the line extends forever off to the right as the domain continues. We are not concerned about the fact that these two pieces do not touch. We don't need them to touch one another. A piecewise function does not have to have its parts touching. What we need is for it to still obey the laws of a function, namely that every input has an output. That's really hard to see in this particular graph, especially at this place of overlap. It looks like, based on the place of overlap, that we have two different values at x is equal to 1. The graphing technology that I use to create this piecewise function does not show the end of one graph and the beginning of the other. What it does show is where they stop and start. We need to be very careful when we're graphing these by hand to show the fact that this graph is going to end and actually belong at this spot, and this graph is actually only going to begin there. And we use some of the logic that we had from graphing inequalities with the closed circle and the open circle to make that vision a reality.